John Newlands, the forgotten pioneer of the periodic table. In the heart of Victorian London, amidst the rise of steam, science, and steel, a young chemist was quietly searching for harmony within the building blocks of nature. His name, John Alexander Rayner Newlands. Born on November 26, 1837, Newlands grew up in a time of discovery, but also a time of doubt for those who thought differently. He studied chemistry at the Royal College of Chemistry, inspired by the great scientific minds of his time. But Newlands was not just a man of formulas and flasks. He was also a lover of music, and it was this unique perspective that led him to one of chemistry's earliest classification systems. In 1865, Newlands made a bold proposal. As he arranged the known elements by increasing atomic mass, he noticed something striking. Every eighth element seemed to repeat in its chemical behavior, much like the octaves in music. He called it the law of octaves. To Newlands, the elements sang a hidden tune. Lithium, sodium, potassium, all shared properties and fit neatly into his musical model. He believed he had uncovered nature's rhythm, but when he presented his findings to the Chemical Society, he was ridiculed. Some scientists mocked the idea. One famously sneered, "Have you tried arranging the elements in alphabetical order as well?" Wounded but undeterred, Newlands published his periodic classification in the Chemical News. It would be one of the earliest structured attempts to group elements based on recurring patterns. Years passed. In 1869, the Russian chemist Dmitry Mendeleev presented his periodic table. Like Newlands, Mendeleev arranged elements by atomic mass, but he left gaps for undiscovered elements and predicted their properties. Mendeleev was hailed as a genius. Newlands remained in the shadows. But over time, scientists began to realize something. Newlands had seen the pattern first. Though he lacked the predictive precision of Mendeleev, his law of octaves had laid the groundwork for periodic classification. Recognition, however, came slowly. It wasn't until 1887, 22 years after his proposal, that the Royal Society of London for Improving Natural Knowledge, known simply as the Royal Society, righted a historic oversight. They awarded John Newlands the prestigious Davy Medal, their highest honor for outstanding contributions to chemistry. The citation acknowledged his pioneering work on the periodic classification of elements, a silent but powerful admission that he had been right all along. The medal was not just a personal victory. It was a statement to the scientific world. Visionaries must not be ignored simply because they think differently. Newlands spent his later years as an analytical chemist, working in a sugar refinery, and later as a chemical inspector for the government. Quiet, methodical, and precise, he never sought fame, only truth. He passed away on July 29, 1898, at the age of 60. Today, students learn about the periodic table as a triumph of order over chaos. While Mendeleev's name is rightly celebrated, so too should we remember Newlands, the man who heard a melody in the elements and dared to write it down. He was not just a chemist. He was a composer of the unseen, a seeker of harmony in matter. His law of octaves was not just a theory, it was an act of imagination. And in the end, the Royal Society's Davy Medal was more than recognition. It was redemption. This is the legacy of John Alexander Rayner Newlands, the forgotten pioneer who gave the periodic table its first rhythm and whose vision, once laughed at, now echoes through every science classroom around the world. Quiz on biography of John Newlands 1. In which year was John Newlands born? A. 1834, B. 1837, C. 1842, D. 1839-2. What is John Newlands most famous for? A. Discovery of electrons, B. Law of octaves, C. Modern atomic theory, D. Discovery of noble gases. 3. Which subject did Newlands compare chemistry with in his classification system? A. Mathematics, B. Astronomy, C. Music, D. Architecture. 4. What was the basis of Newlands' law of octaves? A. Atomic number, B. Atomic volume, C. Atomic weight, D. Valency 5. What pattern did Newlands observe in the chemical properties of elements? A. Every fifth element is similar. B. Every eighth element is similar. C. All metals are grouped together. D. Every second element is similar. 6. In which year did Newlands publish the law of octaves? A. 1860B, 1. 865C, 1. 869D, 1. 8717. What was the initial reaction of the scientific community to Newlands' theory? A. Immediate acceptance, B. Wide applause, C. Ridicule and rejection. D. Nobel Prize nomination 8. Which organization rejected Newlands' work at first? I. Royal College of Chemistry, B. Royal Institution, C. Royal Society, D. British Science Council. 9. Which Russian chemist later developed the periodic table using atomic mass? A. Bohr, B. Mendeleev, C. Dalton, D. Avogadro. 10. What key feature did Mendeleev add that Newlands did not? A. Musical patterns, B. Gaps for undiscovered elements, C. Atomic numbers, D. Color-coded table. 11. Which medal did Newlands receive for his work in 1887? A. Nobel Medal, B. Faraday Medal, C. Davy Medal, D. Lavoisier Medal. 12. When did John Newlands pass away? A. 1887, B. 1895, C. 1898, D. 1913. Where was John Newlands born? A. Manchester, B. Oxford, C. London, D. Liverpool. 14. Apart from chemistry, in which field did Newlands work professionally? A. Electrical engineering, B. Analytical chemistry, C. Physics, D. Mechanical engineering. 15. What was Newlands' lasting legacy in chemistry? A. Discovery of isotopes, B. Classification of organic compounds, C. Early form of the periodic table, D. Formula of water.